Let's start with the last video of this section, nftables, a more universal type of firewall system. In the previous section, we learnt about Firewall D for Red Hat systems. In this video, we will learn about nftables, tables, and chains. Then we will work with nftables. We will also learn to use nft commands. Let's now turn our attention to nftables, the new kid on the block. So, what does nftables bring to the table? You can now forget about needing separate daemons and utilities for all of the different networking components. The functionality of IP tables, IP6 tables, EB tables, and ARP tables is now all combined in one neat package. The NFT utility is now the only firewall utility that you'll need. With nftables, you can create multi-dimensional trees to display your rule sets. This makes troubleshooting vastly easier because it's now easier to trace a packet all the way through all of the rules. With IP tables, you have the filter, NAT, mangle, and security tables installed by default, whether or not you use each one. With nftables, you only create the tables that you intend to use, resulting in enhanced performance. Unlike IP tables, you can specify multiple actions in one rule, instead of having to create multiple rules for each action. Unlike IP tables, new rules get added atomically. nftables has its own built-in scripting engine, allowing you to write scripts that are more efficient and more human-readable. If you already have lots of IP tables scripts that you still need to use, you can install a set of utilities that will help you convert them to nftables format. We will now look at nftables, tables, and chains. If you're used to IP tables, you might recognize some of the nftables terminology. The only problem is, some of the terms are used in different ways, with different meanings. Here's some of what I'm talking about. Tables in nftables refer to a particular protocol family. The table types are IP, IP6, INET, ARP, Bridge, and NetDev. Then, chains in nftables roughly equate to tables in IP tables. For example, in nftables you could have filter, root, or NAT chains. Let's get started with nftables. We will start with a clean snapshot of our Ubuntu virtual machine and install the nftables package. Enter this command. Now, let's take a look at the list of installed tables. You didn't see any tables, did you? So let's load some up. If you look at the nftables.conf file in the etc directory, you'll see the beginnings of a basic NFT firewall configuration. This is the file. Let's look at the breakdown of what all this means. We will start with the first line. Although you can create normal bash shell scripts with nftables commands, it's better to use the built-in scripting engine that's included with nftables. That way, we can make our scripts more human-readable, and we don't have to type NFT in front of everything we want to do. Next is flush rule set. We want to start with a clean slate, so we'll flush out any rules that may have already been loaded. Table INET filter. This creates an INET family filter, which works for both IPv4 and IPv6. The name of this table is filter, but it could just as well have been something a bit more descriptive. Chain input. Within the first pair of curly brackets, we have a chain with the name of input. Type filter hook input priority 0. Within the next pair of curly brackets, we define our chain and then list the rules. This chain is defined as a filter type. Hook input indicates that this chain is meant to process incoming packets. Because this chain has both a hook and a priority, it will accept packets directly from the network stack. Finally, we have the standard rules for a very basic host firewall, starting with the IIF rule that allows the loopback interface to accept packets. Next is the standard connection tracking, or CT rule, which accepts traffic that's in response to a connection request from this host. Then there's a commented out rule to accept secure shell and both secure and non-secure web traffic. The CT state new indicates that the firewall will allow other hosts to initiate connections to our server on these ports. The IPv6 rule accepts neighbor discovery packets, allowing for IPv6 functionality. The counter drop rule at the end silently blocks all other traffic and counts both the number of packets and the number of bytes that it blocks. This is an example of how you can have one rule perform two different actions. If all you need on your Ubuntu server is a basic no-frills firewall, your best bet is to just edit this etc nftables.conf file to suit your own needs. Quit from here and reset. Move to root and open nftables.conf file. For starters, let's remove the comment symbol from in front of the TCP dport line and get rid of ports 80 and 443. Note that when you're only opening one port, you don't need to enclose that port number within curly brackets. When opening multiple ports, just include the comma-separated list within curly brackets, with a blank space before the first element and after the last element. Load the configuration file and view the results. Now, let's say that we want to block certain IP addresses from reaching the secure shell port of this machine. We can edit the file, placing a drop rule above the rule that opens port 22. Move to root again. Open the nftables.conf file. We have to now edit the file. Add these lines. After we reload the file, we'll be blocking SSH access from two different IPv4 addresses. Now we will learn to use NFT commands. There are two ways to use the NFT utility. You can just do everything directly from the bash shell, prefacing every action you want to perform with NFT, followed by the NFT subcommands. You can also use NFT in interactive mode. For our present purposes, we'll just go with the bash shell. Let's first delete our previous configuration. And create an inet table, since we want something that works for both IPv4 and IPv6. We'll want to give it a somewhat descriptive name, so let's call it Ubuntu_filter. Next, we'll add an input filter chain to the table that we just created using this command. In this command, the first input after the Ubuntu_filter is the name of the chain. Within the pair of curly brackets, we're setting the parameters for this chain. Each nftables protocol family has its own set of hooks, which define how packets will be processed. For now, we're only concerned with the IP, IP6, inet families, which have these hooks: pre-routing, input, forward, output, and post-routing. Of these, we're presently only concerned with the input and output hooks, which would apply to filter-type chains. By specifying a hook and a priority for our input chain, we're saying that we want this chain to be a base chain, which will accept packets directly from the network stack. You also see that certain parameters must be terminated by a semicolon, which in turn would need to be escaped with a backslash if you're running the commands from the bash shell. Finally, we're specifying a default policy of drop. If we had not specified drop as the default policy, then the policy would have been accept by default. Every NFT command that you enter takes effect immediately, so if you're doing this remotely, you'll drop your secure shell connection as soon as you create a filter chain with a default drop policy. Verify that the chain has been added. And you should see something like this. That's great, but we still need some rules. Let's start with a connection tracking rule and a rule to open the secure shell port. We'll then verify that they got added. So type these commands. Then enter command to view the table. Okay, that looks good. You now have a basic, working firewall that allows secure shell connections. We forgot to create a rule to allow the loopback adapter to accept packets. Since we want this rule to be at the top of the rules list, we'll use insert instead of add. Run the commands with me. Now we're all set. But what if we want to insert a rule in a specific location? For that, you'll need to use list with the -a option to see the handles rule. So here I am doing that. As you can see, there's no real rhyme or reason to the way the handles are numbered. Let's say that we want to insert the rule about blocking certain IP addresses from accessing the secure shell port. We see that the SSH accept rule is handle 3, so we'll need to insert our drop rule before it. Our command to do that would look like this. Enter the command to see the table. we got the handle as 5. So, to place the rule before the rule with the handle 3 label, we have to insert to position 3. The new rule that we just inserted has the label handle 5. To delete a rule, we'll specify the rule's handle number as shown in this command. Then we will list the table again. As is the case with IP tables, everything you do from the command line will disappear once you reboot the machine. To make it permanent, let's redirect the output of the list subcommand into a configuration file. Run this command. Due to a quirk in the bash shell, we can't just redirect output to a file in the etc directory in the normal manner, even when we use sudo. That's why I had to add the sh-c command with the nft list command surrounded by double quotes. Now, when we look at the file, we'll see that there are a couple of things that are missing. So root it, and move to the etc directory. Open the file. Much better. Let's test it by loading the new configuration and observing the list output. That's all there is to creating your own simple host firewall. This brings us to the end of this section. In this section, we've looked at 4 different front ends for the NetFilter firewall. We first looked at our trusty old friend, IP tables. We saw that even though it's been around forever and still works, it does have some shortcomings. We then saw how Ubuntu's uncomplicated firewall can vastly simplify setting up an IP tables-based firewall. For you Red Hatters, we looked at Firewall D, which is specific to Red Hat type distros. Finally, we wrapped things up by looking at the latest in Linux firewall technology, nftables. The next section will be about encrypting and SSH hardening. See you there.